Yeah, good evening, everyone. Joining up, let's start off. Comes on, everyone. So this was the last thing we did, and I gave you homework to find velocity of D and velocity of E. I hope everyone tried that. Sure, let's see how to do this thing. Did you guys try this or forgot? Forgot. How to find velocity of D and E? Try. I'll give you a minute now. So for this rhombus kind of thing, find the velocity of that point D here and point E here. Let's get this. I hope everyone has given the test. Right. I'll be posting the results. The next paper will be online tonight at around 10 o'clock. It'll be there till next Tuesday. How is the test units and dimensions? Easy? I think some of you guys felt there are some 1 or 2 corrections. Let me check it out. You can just send it to me. Some of you sent. I'll check it after the class. Yeah.
In some questions, there were things that were not yet taught, like viscosity and all those things.
Let me check it out. I think maybe I should have seen that. कितना question है? एक दो?
Yes, like that.
2 questions.
चलेगा ना. I'll just cancel those questions. Don't worry.
Questions had velocity. Viscosity.
That is okay. And like I told you, that's the reason I don't like the chapter. Because if the entire portion gets over, right, it won't matter. But the beginning, this is what will happen. Anyways, we'll see. End of the class, whatever things you have any issues. Answers: velocity of D and velocity of E, everyone. Try. You got a minute. Wherever possible, I try to give you the formula, but I think 1 or 2, I think even I forgot. How do we find velocity of D and velocity of E? Others, do keep your cams on. Who is absent? Remember this thing, whenever you get any weird point, right, always try to get the coordinates and then from there you try to differentiate. So using this logic here, last thing we did, if you try to find the coordinates of D, this would be how much? 5x by 2, and this would be some y. And from here we can clearly see phi cos theta is equal to, plus 5 is given now. Okay. Sin theta is y by 5 and cos theta is 5x by 2 in 5. So that is x by 2. And if I differentiate this dy by dt, that will give me 5. Sin ka differential is cos theta d theta by dt. And if I differentiate this, I get cos theta minus sin theta d theta by dt is equal to half dx by dt. If you can divide these two, you end up with dy by dt by cos theta d theta by dt by dx by dt is minus 2 sin theta d theta by dt minus 5 by 2 cot theta. So there. So dy by dt is minus 5 by 2 cot theta dx by dt. And we already calculated dx by dt is nothing but u by 10. So minus, this is cot. Five and 2 will cancel, minus u by 4 cot theta. Perfect. So you want to find velocity of d. So the position vector of d, so velocity of d will be d x coordinate dt I cap, d y coordinate dt j cap. Agreed? You just find the x and y coordinates and differentiate them. dx dy dt is nothing but dx, that is 5x by 2. That is 5 by 2 dx by dt I cap. And the y coordinate is dy by dt j cap. And dx by dt is u by 10. So that would be u by 4. No. U by 10, no? Yeah, u by 4 I cap. Plus dy by dt is minus u by 4 cot theta j cap. That's the velocity of d as function of theta. Check. So this coordinates of d would be 5x, 2, y. That is your x coordinate of d and y coordinate of d. So dx by dt, anyway, we know in the last class we did this. You just need to find that y in terms of x. Actually, इतना करने का जरूरत नहीं था. You could have done tan theta is equal to y by 5x by 2 and differentiated. No, that also will be bad. We get a chain rule. This is fine. Keep everything in terms of the 5 meter ka thing and do it. You could have done that. Tan theta is equal to 5 by 5x by 2. Then this will be 5 is equal to 5x by 2 tan theta. Differentiate first x and then theta. Same thing you will get, but it's a little more complex. Do check out the steps. I think you can do the same thing for point t right now. Point t coordinates will be what? 5x plus 3x by 2. That is 6.5x, comma, some y coordinate of v. You can find that and differentiate it. I'll leave that to you. You can try. But the idea is the same. Get the coordinates and differentiate and finish it off. Actually, you can guess that y part also. If this is y, if this is 5y, won't this be 3y? That means velocity of d and velocity of e will be in the ratio of 5:3, no? You can actually guess the y component velocity of e more easily without doing anything. This would be 3y by 5. there. Check this out. All clear with this? You guys try for E definitely, yeah? Meaning you can actually play around a lot. If they really want to torture you, you can ask you to find the velocity of this point in the middle of the rod, isn't it? So I can ask you any point on this thing. You just need to find the coordinates and differentiate and finish it up. Clear? So with that, we are done with constraints. So next thing, we'll start off with Newton's laws. A little bit of a theory. All clear with this? Any doubts on this? Abhinav, clear na? Vartika, Yasha, Ronak, clear?
Yes, sir.
Ritu, Arjun, clear?
Yes, sir.
Going ahead. Newton's first law. So what this thing says, body continues to be in a state of rest. Or uniform motion. Until and unless it is acted upon by a force. Right? So what this thing simply says is a body will continue with constant velocity or it will be at rest if until unless you don't apply a force. So this thing gives us two ideas here. The first law talks about, it tells us something called about a force. So if someone asks you what is force, you can simply say force is something which will change your state of the body. Maybe it will start making it move or it will make it stop or something like that. It gives us concept of force. And second thing, inertial frame. Because in this, if you see the word, how do you know something is at rest and how do you know something is moving? Remember that in kinematics, we defined inertial frame and non-inertial frame. So great. So let's talk about this force. So primarily, there are four types of forces. All forces in the universe can be classified into four types. Gravitational force. Now this comes due to interaction between masses. They have a very long range. Range is something like up to what distance can you interact? Up to infinity. And they're pretty weak actually. Think about it. When you lift your pen, the entire earth is attracting the pen and with just two fingers, you're lifting the pen. The gravity of the entire earth, you're able to balance with just your one single hand. This is the first type of forces, gravitational forces. Second thing is electromagnetic. This is due to interaction between charges. The range is in meters. These forces are strong. There's a third force, nuclear forces. This is the interaction between nucleons, that is between neutrons and protons. This is the force inside the nucleus. This range is very small, 10 power minus 15 meters, and these are pretty strong. Think about it in school, right? Your science teacher must have taught you like charges ripple. So if you take an atom like sodium, there are 11 protons, which are all are positive charges, which are sitting in such a small nucleus. Shouldn't they ripple and fly off? But they don't. So people said there must be something else which is keeping them balanced, and that is what we call as a nuclear force. So we actually figured out that way. No one has actually seen it in an experiment and stuff, but that's the only way to explain. There's a fourth force called, weak forces. These are forces inside the proton and inside the neutron. These are something which people are still studying. We don't have much of an idea about it. So we'll not deal with it. So primarily our main focus will be on these two, gravitation and electromagnetic, in the entire 11th and 12th. Previous page here. Have a look at this. Clear? Palaksh, clear, right? Yeah. Have a look at this thing. So primarily we deal with the main things, the gravitation, electromagnetic. Can I turn the page? Turn the page. Now in mechanics, we deal with normal reaction, tension forces, spring forces, and friction. Now friction, we have a separate chapter for it. We will deal with that in the later on. Spring forces we'll do in the end of the chapter. So currently our main focus will be on normal reactions and tensions. So what is this normal reaction? We have two surfaces in contact with each other. Right, the nucleus of the molecules repel each other, generating a force along the common normal. That means, right now you're keeping your hand on the table, right? What you're feeling is actually a repulsion force. You think you're touching the table. In reality, you're never touching the table. What you're experiencing right now is the repulsion between the molecules, on your hand and the molecules on the table. If you can actually touch a molecule, there'll be a nuclear fusion and there'll be an explosion. That's the whole principle behind a nuclear bomb. You take hydrogen or hydrogen atoms, and when you bring them pretty close, at one point, right, when the distance becomes less than 1 Fermi, the nuclear force will act and they'll stick together. The hydrogen becomes helium. That is what we do. And in that process, we release a lot of energy. We call them, this is the nuclear fusion reactions. So in reality, when you're touching something, you're never really touching it. What you're doing is actually, you're experiencing the repulsion. So if you just slap someone, you can tell them, see, I didn't touch you. That guy will punch you back and say, even I didn't touch you. That really doesn't work. So what kind of force is normal reaction? It's an electromagnetic force. This is what I said. All forces in the universe, right, can be classified into those 4 forces. Normal reaction is something which we named it, but in reality, it is an electromagnetic force at a molecular level. So if you have surfaces like this, and if you observe, so this molecule is repelling this molecule is repelling here, this molecule is repelling here, and so on, you can clearly see that symmetry this is your common normal. You could have done the other way around also. So this guy is repelling this, and this guy is repelling this, this guy is repelling this, and repelling this, and so on. So this molecular repulsion is always along the common normal. When you say common normal, if you take a wedge and a block, you take a block and a ground, or you take a wedge and a sphere, or you take a sphere and a sphere. So a common normal will be, this is a common normal. For spheres, it is a line joining the center. Common normal. For a flat surface, all these are normals. For a sphere, all these are normals. So among these two, there is one common normal. That is this guy in the middle, isn't it? I hope you're getting what is the meaning of a common normal. A normal which is same for both of them. Have a look at this. So this is how you get normal forces, and this is the catch. Do have a look at this. Clear? Any doubts on this? Idea is important. You should know like what each force does and all. A bit of a thing we'll do. We have some good problems on based on equilibrium and stuff. Today we'll do free body diagrams and stuff. Quite an important thing. Literally every chapter you will see there'll be a free body diagram, and this is where it starts. Clear? Turn in the page. Next thing, tension forces. The first thing, when you say tension, it is like tension is actually not of a force. Tension is actually state of the material. But then again, we use it in a wrong way. Because of tension, you get a force. Think of like this. When you're angry, you start shouting. So shouting is an action. Because you're angry, you started shouting. Because there's a tension, there's a force generated. So tension is not actually a force. Tension is a state of the material. Just like angry, there's a state of yourself. When you're hungry, that's a state. When you're happy, that's a state. When you're happy, you're smiling and you're doing all good things. Man. That's an action. Because of that, something happens. But then again, need not go so deep. End of the day, books may everyone doesn't care. But just have an idea like that. So when a body is under tension, so this is what we see. Body is under tension. It's like saying when you're under stress, you can't sleep properly. So because you're under stress, you couldn't sleep properly. So something happened because of that. So when you're under tension, it generates internal restoring forces. This is a internal restoring forces. Look at the word. Internal forces are inside. Restoring, these forces are trying to restore you forces. Internal restoring forces which try to bring the body back to natural state. So whenever you try to deform the body, that is to stretch it or elongate it, it will always try to come back to the natural state. So this internal tension restoring forces, this thing is what we call as tension forces. So the actual name is tension force, but then we are lazy, so we will simply write as tension. We will write this as tension. So just remember, when someone says tension in the string, it is actually not a force. You're talking about the state of the material. You are supposed to say tension force, but we are lazy. So we'll just call it tension. Next thing. So what is this tension basically? So tension is because of deformation of the bond structure. Whenever you're trying to stretch, the molecules are being pulled apart or pushed apart. this creates, kind of internal forces, which we will deal with in another chapter called elasticity. Right now, we'll not talk about it much. The bond structure actually gets, distorted, and the molecules will try to push it back to come back to the natural state. So tension is also an electromagnetic force. So tension, normal reaction, friction, spring, all these four are electromagnetic forces. Your mg is your gravitation force. Check it out. This is the second force that we'll deal with. So currently, these are the two forces we will deal with up to at least one or two classes. For springs, we will have a separate session for it completely. And friction, we have a full chapter only. So these are the four forces we will deal, but currently, these are two we will play around with. Have a look at this. Clear? Any doubts on this? Anyone not clear? Clear? Can I go ahead? That is about the, a little more is there. When you talk about tensions, primarily, right, we will encounter two kind of things. One is a rods. A rod can pull and push. Meaning, if you take a rod and if you try to pull it, if we pull the rod, it pulls back. So that person, the force would be, will pull him back. Same thing. If you push the rod, it will push you back. I know it looks kind of basic, but telling you that's how we go for basics. They have to be very clear. It pushes you back. I'm becoming good at drawing, right, nowadays. Yeah. Second thing, what about a string? This we talked about it a bit before. Strings always pull. They can't push. That's the main difference between a rod and a string. If you try to push, they become slack. So be careful with that. If you take a string and if you try to push, the string becomes loose. There, these are the two things we deal with. Tensions in the rod and tensions in the string. That's your first law. The definition, there are four types of forces and mechanics ka normal reaction and tension forces. Clear? Any doubts on this? Please ask. Clear? Can I go ahead? Next thing, before jumping into the second law, we need to define something called momentum. The symbol is P bar. Momentum is given by mass into velocity. What is momentum? I know mathematically it means mass into velocity, but can someone tell me what is momentum? What does it mean? Remember this thing, huh? In physics or in science, anything, not only in science, anything, right? There are always two definitions. A one technical definition for which you get marks writing in the exam. A second definition for you to understand what the hell it means. You should have both the definitions, or else you won't understand what it means. You know, you will just have a proper scientific definition without having any understanding. So if I ask you this, what is momentum? What will you tell me? It need not be a definition. It could be even an example to make you understand what it means. What do you guys think momentum is? I don't know.
It's the impact the body is going to have.
Impact. Yeah, kind of. Yeah. Let me give you my version of this. Okay. How do I explain this? I'll ask you something. If something is going with a speed of 1 centimeter per second, 1 centimeter per second, can you stop it? If something has a mass of 1 gram, can you stop it? So if a local train is going with 1 centimeter per second, you will stand in front of it. So a 1 gram bullet goes with 1 kilometer per second. Will you stop it? Suddenly answer change. So when I said speed is 1 centimeter per second, you are not scared of the speed of the train. You are scared of the mass of the train. When I said 1 gram, you thought you could stop it. But when I said 1 kilometer per second, you got scared. You didn't get scared of the mass. You got scared of the velocity. What are you actually getting scared of? The mass or the velocity? The product. Isn't it? So like what of you, some of you are saying impact and truck hits the car. Yeah, it means the same thing. I just kept it in a more formal way. So if someone asks you what is momentum, this is what I say. Higher the momentum, more difficult to stop the body. So when someone asks you, right, speed is 1 centimeter per second, you should ask him, boss, what is the mass? I'm pretty sure. Even if a train goes with 1 centimeter per second, you won't go and stand in front of it. It will just crush you and go ahead. Right? So because you're scared actually of the mass of the train. Higher the momentum, more difficult to stop the body. Again, a non-technical definition, but it gives you that context, okay, what it means. Now, this will be valid everywhere in physics. Whenever we learn something, we'll always have a technical definition. We'll always have a definition for us to understand. Higher the momentum, more difficult to stop the body. So next time when someone asks you, is it easy to stop? You should actually ask about the momentum, not the mass or the velocity. Second thing, we know kinetic energy is half mv square. I wrote this before in units and dimensions. Multiply mass and mass. So this will be mv whole square by 2m. This becomes p square by 2m. And momentum is given by root over 2 times mass into kinetic energy. There's a relation between momentum and kinetic energy. Have a look at this. So this is a little about momentum. And momentum also, right? It depends on the frame of reference. Meaning, if a block of mass m is going with speed v, we have person A who is at rest. And we have person B who's traveling with v. If you ask A what is the momentum, he will say m into v. If you ask B what is momentum, he will say 0. Isn't it? Depending on who is seeing the block, they'll give different answers about momentum. Since v relative is 0, we will think block is not moving only. So momentum depends on the frame of reference. Force is frame independent. Whether you're running or you're standing, if you apply 10 newtons, it will be 10 newtons only. Force doesn't care from where you are watching it. Mass is again frame independent. Mass doesn't care where you're watching it. So there are certain quantities which will depend on frame, some will not depend on frame. Example, force and mass won't depend on frame. Momentum depends on frame.
Sir, but force is mass into acceleration. So won't it
So
depend on, like, if a block is on
Mehan. The first problem is, who told you force is mass into acceleration?
it's a delta m.
We'll see what it is. The first assumption is you started with a wrong assumption. And second thing, remember, if something is accelerating or something, it's a non-inertial frame. You can't apply Newton's laws of motion. There are multiple blunders in that one definition, what you said, but let's see. Clear with this, everyone? Easy. Next one, Newton's second law. So Newton's second law, it is the force acting on a body is proportional to rate of change of momentum of the body. So Newton's second law is actually this: force is proportional to rate of change of momentum. Now here, if you remove the proportionality constant, you'll get k is k dp by dt. And if you take SI units, that is meter, kg, and second, the k value comes out to be 1. Means if you take something else now, like CGS units or foot pound square unit, that k is not 1. So don't say F is dp by dt. That is also wrong. F is proportional to dp by dt, depending on which units you're taking. So this F becomes dp by dt. And that is nothing but dmv bar by dt. Then we use the product rule, m into dv by dt plus v into dm by dt. This is the actual equation. Now, if the mass is constant, which is most of the cases in all the problems, we have a separate chapter called, variable mass system in collisions. There we will deal with, what happens if mass changes. But for now, at least for the next 4-5 chapters, we will handle when mass is constant. If mass is constant, the term dm by dt becomes 0. Then your equation becomes F is equal to m into dv by dt. And we know dv by dt is nothing but acceleration. So F is equal to ma is actually derived under a special case when mass is constant. So be careful, don't use F is equal to ma blindly. You need to check whether mass is changing or not. There, have a look at that. Do check out this page. Ask me if you're confused. Others, do keep your cams on.
First.
Yeah.
So this is so F is equal to MA won't be valid for rockets, right?
Nope. It's not valid. We have a section rocket propulsion karke. We will do some pretty nice problems. But that is later on. I think 5th or 6th chapter. Can I turn the page? All clear with this? So from this, if you see, we get F is equal to dp by dt. So dp bar is equal to f dt. And if you integrate this, this will give you P final minus P initial. That is nothing but change in momentum. Which is integral f dt or area under ft graph. So if someone gives you force versus time graph, we have done this in kinematics. The area under ft graph will give you change in momentum. Remember, this is the positive area. This is the negative area. So here also you have to subtract the areas here. So area under ft graph gives you change in momentum. Let me show you one question where how mass changes, how it looks. We'll do 1 or 2, and then we will go ahead. Clear? Turn the page. Vartika, clear so far? Vartika, there? Clear? Ritu, Ali, got this? Vidyut, Neil, clear so far? Now, example. Let's say we have a truck, a trolley, which is going with a constant speed u. Mass is some mass is m. And let's say it started raining. And rainwater is collected at a rate of lambda kgs per second, means every second lambda kgs of rainwater is falling into the truck. So they'll ask a question like this: find the force required to maintain the speed. Now, this is what people do. They'll say, okay, since u is constant, acceleration is 0, and f is equal to ma, therefore f is equal to 0. This is a blunder. Why?
dm by dt.
Why? We can't use this. This is not valid. Mass is changing. But this is what happens in the exam. Huh? Right now, it might look like, okay, obvious, right? But examiner in that tension and all, it is not obvious. People do this thing. The speed is constant, acceleration 0, force is ma, force is 0. You have to be very careful. That's what I'm saying. See, every time you write this thing, when it is wrong also. Because this is one thing that I observed. You know it is wrong, huh? But you will realize that after the exam gets over. So when we write it down like this, when you see this question, you'll understand, ye wrong ho sakta hai. So be careful about this thing. It is not only your subject. You should know where you can do mistakes also. Because you have to be aware. People say, sir, I'm doing a lot of silly mistakes. You do a lot of silly mistakes because you're not aware. When you see a question and you can feel, right, ye question mein na, these are the kind of mistakes I can do. That is also a part of training. It is not always about getting the right answer, but it is also about thinking, okay, in this question, this is a mistake I could have done. Once you start thinking like that and start solving questions, your silly mistakes will start going down. Actually, subject will improve much better. Instead of doing, 400 questions, I would prefer you do 100, 150 questions, but do them properly, right? In that, try to do variations. In that, try to figure out what mistakes you can do. You're getting it? Go deep rather than trying to solve lots of varieties. Physics works that way. Maths, on the other hand, requires brute force practice. So all subjects are different. You have to study them differently. You can't apply one strategy to another. So how do we do this? We'll go back to the basic definition. F is mdv by dt plus v dm by dt. So this is f. This term will be 0. V is v only. Dm by dt is lambda. So f is u lambda. Dm by dt is rate of change of mass. No? This term is lambda. Mass is changing at a rate of lambda kgs per second. Simple. Just an example. Let me show you a question, a better one. Clear? Any doubts on this? Next one. Now you guys try this question. Same thing, we have a trolley. Mass m. Initial velocity is 0. Initially, trolley is at rest. rainwater is collected at a rate of lambda kgs per second. And you're applying a force F. Case 1, F is equal to F naught, a constant force. Case 2, F is equal to T. Force is changing with time. Find velocity of the trolley after time T. So we have a trolley at rest. You're applying a force F, mass is m. Initial velocity trolley is at rest. And the rainwater is falling into the trolley at a rate of lambda kgs per second. Case 1, apply a constant force. Case 2, apply a force which is changing with time. Find the velocity of the trolley after time t. Let's get this. Try, you got 2-3 minutes. We're just doing one per sample here, but we will do more of this thing in a variable mass system. Just give it a try, get some water and go. Any answers? FP by Arjun, that is wrong. You can put it in that formula and integrate. That will be quite long. There's a much easier and faster way, but think I'll give you a minute more. That might be, that is right, Anika. So case 1, use this thing, integral f dt is change in momentum. So here initial f naught is constant. So integral f naught dt 0 to t. This would be p final minus p initial. Now here, this is f naught into t. The thing which you're missing now, this is final mass into velocity final minus initial mass into velocity initial. This term is 0. What is the final mass? Mass of the trolley plus rainwater is lambda into time now. Mass of that system is not constant. So this will be f naught t by m plus lambda t. Clear? Same thing you can do for the B part. This time it would be f dt 0 to t. This would be m final, v final minus m initial, v initial. Once you got the idea, it is easy. F is t, so this would be t square by 2, and mass final will be m plus lambda t. M is the mass of the trolley, and lambda t is the rainwater. This is trolley ka mass. This is rainwater ka mass. That's the total mass of the system. And we get V final is equal to t square by 2 into m plus lambda t. You wanted to use this formula, you can do that, m dv by dt plus v dm by dt. You can't, for the second one, you won't be able to get it. You'll get a differential equation, which we don't know how to solve right now. They'll teach you in max. But if f naught is constant, you can integrate and get it. Quite lengthy it is. You get a ln ka terms and everything, but final answer will be the same. Check it out. The actual equation is f is dp by dt. That's a more powerful one than m dv by dt plus v dm by dt. So m dv by dt plus v dm by dt is actually a subset of that f is dp by dt. So stick to the basics. Check it out. This is how you'll get questions whenever there's a variable mass. You can't use a regular f is equal to m and solve. You'll get all wrong answers. So be careful. More about this we will deal in a separate chapter, but you should have an idea 1 or 2 problems. So any doubts on this? Anyone not clear? Please ask. Clear? Can I go ahead? Any doubts on this? Anyone not convinced with anything here? Please ask. To your cam is blank. Venkatesh, I can't see you. Others do make sure I can see your full face. And someone left in the middle of that class. So who is this? Chalo, I'll catch them. Next thing. Newton's third law.
So can you go back to the previous page just for a second? Yes, sir.
Newton's third law. For every action, there is an equal and opposite reaction. It's a hopeless statement it is. Right? The problem with that statement is, tell me one thing. Suppose if I give you a handshake, or if I, let's say, if you touch the table, did you touch the table first, or did the table touch you first? Or did both happen at the same time?
Both happen at the same time.
So when you say action reaction, right? For example, it is like, let's say my hand is there, I shouted on him, right? He got angry and he hired 10 rowdies to beat me. Now, if you see, I did something, and for that, my hand did something else. So there is an action and there is a reaction. See, my hand is so happy actually. Yeah, I have a rowdies. So the problem with this, action reaction statement is something happened, and in order to counter that, you did something. But the problem here is when you touch a surface, right? At the same time, the surface is also touching you. So there is nothing called action and reaction. So simply saying action reaction, there's always a time delay. But here you won't find time delay. So that definition is not actually proper, but then again, chalta hai. School mein to that much will do. So let's define it in our way. So when two bodies interact, the force between them first thing, equal in magnitude. Both the forces should have equal magnitude. Opposite in direction. Till here it is kind of obvious. Along the same line, the forces should be on the same line. If they're not on the same line, they'll produce torque. The body will start rotating. At the same time, there should not be any delay between them. Act on two different bodies, they should not be acting on the same body. And must be of same nature. Same nature meaning if one is gravitation, other also should be gravitation. You can't have one force electromagnetic and one force gravitation. The other 6 points. So for something, for the action reaction pair, which we say pair, we'll just call it pair of forces. But it doesn't matter. We can just call it action reaction pair if you want. So they should satisfy these 6 conditions for them to be a pair. So forces always come in pairs. You won't get a single force. If you're applying F on something, that will act F on you in return. So remember the statement of forces always come in pairs. You can't have a single force alone standing somewhere in nature. Straightforward definition. So let's see a question on this, a theoretical question. They did ask something like this before. Do check out the 6 points. Ask me if you're confused. Clear? Let's see a question. Let's say we keep a block on the ground. I can take it as an example also, but okay. Block is placed on a floor. So if I just try to draw the forces on this body here, M. See the forces. 1 mg, your weight. Second is your normal reaction. This is your weight. So this will be mostly a statement question. The simple question are mg and then action reaction pair. I'll just call it action reaction pair. It will be easy for you to understand, but remember there is a wrong thing to say actually. But okay. Yes or no? Simple question. If it is not, then where is the pair? If it is, then fine. Think I'll give you 30 seconds, then we'll discuss. Always take time, when there is a time for you to think, don't be in a hurry to answer. Take 10-15 seconds, socho. You should develop that patience. Take 15-20 seconds to think about it. Okay. Now, let's try to look at the points, okay? First thing, they should be equal in magnitude. Chalo, they look equal. They look equal. Second, they're in the opposite direction. Fair enough. Along the same line, fair enough. Same time, fair enough. On two different bodies, gone. They're acting on the same body. They should be of same nature. Mg is gravitation, normal reaction is electromagnetic. Are you getting this? Mg and N are, this is gravitational force and that is electromagnetic. They're not a pair. This is gravitation. And this is electromagnetic. So where is the pair then? Remember, where is other pair of forces? Yeah, right, Neil. So the thing is, this is what is happening. When you wrote this weight mg, Earth is also there now. Now think about it. Who is attracting the block? The Earth. In return, the block will attract the Earth upward, isn't it? This is a force on the Earth due to block. This is a gravitational force on Earth due to block. So the block attracts the Earth attracts the block. So these two are a pair. This is a normal reaction. This is a normal reaction. Think about it. The molecules between the block ka surface and the floor ka molecules are repelling each other, isn't it? So the molecules on the floor and the molecules on the surface, they both are repelling each other. So these two are a pair. So this is a repulsion between the molecules on the surface. These two will be a pair. These two will be a pair. N and Mg are not a pair. The answer is no for this. Have a look at this. So when you're standing on the floor, the molecules on your feet and the molecules on the floor are repelling each other. So the floor is pushing you up and you're pushing the floor down. This is a normal force on block due to floor. This is normal force on the floor due to block. See, they're acting on two different bodies along the same line, equal in magnitude, at the same time, same line, same nature. It will satisfy, all six are satisfied. Floor due to block. Be careful, simple mains level question. This is how people get trapped. Again, in a flow. That's a different thing, Mujan. We will see calculation later on. What is the values that we are not interested right now? We'll see that later on how to calculate. Coming up next, that is the next part. All clear with this? I hope all got this Newton's third law thing. So if you think N and Mg is a pair, sometimes people do get confused. Think like this. And suppose if this is the Earth and if the block is in the air, it is flying in the air, it's falling down. Mg, where is the normal reaction? There's no normal reaction, right? It is not touching the ground only. If the block is falling from a building, it does not touching anyone. So where is the normal reaction? So this Mg and this Mg are a pair. There is no N only here. Please check this out.
Could you show the last page?
This one?
The last, the
Previous
question.
one? Yeah.
Yes, sir.
All got this? Any doubts on this question? What exactly, nah, it is not. Malika, we discussed now what is normal reaction. Whenever you touch something, there's repulsion between the molecules. So if you say it is a weight, chalo, then tell me this thing. Suppose if you have 100 kg, if you have 50 kg, right? And if you put this thing, so do you mean to say normal reaction is 100 kg or 150 kg? Depends, right? If there's only one block, it will be something. If I put 3-4 blocks, it will be something else. It's not equivalent to the weight. There's no guarantee it should be equal to weight. Ho sakta hai, but there's no guarantee. Right? All clear with this? Next thing, free body diagram. We call it FBD. It's a pictorial representation of forces acting on the body. Now be careful here. We should draw, whenever you're drawing the free body diagram, whenever I ask you to draw the free body diagram of a body, we should draw forces acting on the body. We should not draw forces given by the body. For example, just think of yourself. Whenever you're drawing an FBD, right, you're getting confused, think you're the block. If I ask you to draw your FBD, now look at that. Earth is pulling you down. The chair is pushing you up. The hand on your table, the table is pushing your hand up. You're getting it? These are the forces acting on you. You should not draw. You're pushing the floor with your foot. That you should not draw. The floor is pushing you up. That you should draw. You're sitting on the table, you're pushing the chair down, that you should not draw. You should draw the forces acting on you due to others. You should not draw the forces, given by you. So how do we draw this? Steps to draw an FBD. Always, don't try to mug up the formulas, mug up the process, the steps. First thing, when you learn like that, it becomes easy for you to solve, because our complex problem is nothing but 2 to 3 easy problems. Choose your system and draw with the same orientation. Meaning, suppose if you have a block and a wedge. Now here, your system can be only block A, your system can be only block B, your system can be everything, total A and B. Now you have to draw with the same orientation. For example, if I ask you to draw the FBD of A, draw A like this only, you're getting it? Keep it with the same orientation. Some people draw like this A. Don't do that, this is wrong. Keep it, meaning there's nothing wrong, but unnecessary confusion. Keep it with the same orientation. If it is at an angle, keep it at an angle. If it is some looking weird, keep it like that only, weird. Again, I'm teaching with, all these chapters with the mind, rotational mechanics will come. That is in 6th or 7th chapter. So it is all for that chapter actually. So this is the base building. We are building the base. So when you're more systematic, you learn, it will become more easier for you to go ahead. Some people like to draw like this. They like to draw A as a point and then write forces. I don't prefer that, because rotation में बाद में देखेंगे, the forces don't act at a single point. The forces will act at different positions. Even the distance will matter. Where is the force acting? So then you will get trapped unnecessarily. Suddenly you have to change the way you're thinking for that chapter. So keep it simple. Always draw a full body with the same orientation. This is step 1. On the page. Step 2. Draw the weight vector downward. Third, for every point in contact, draw a normal reaction. For example, let's say you have a sphere stuck in a thing like this. If you see there is one contact, there is one contact, and there is one contact. Draw normal reaction with appropriate symbols. So in this case, this is pushing. Let's call it N1, N2, and N3. Remember, the forces should be towards the normal, and the normals meet at the center. You have to be precise. When I say appropriate symbols, N1, N2, N3, don't take N, 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 N. Doesn't make sense. All three need not be equal. If there are strings and rods and springs, so if there is a spring, apply a spring force. If there is a string, apply a tension force. For every string, spring, or rod, draw tension and spring forces. Have a look at this. So let's try to draw a video for some shapes, and then we'll do a few problems also there. All clear with the steps. So this, right, is like an algo we will be seeing later on. So this is like, if in terms of computer ka thing, right? If you're a software coder or something, this is an algo for drawing an FBD diagram. So later on we will see it's like nested algorithms. You want to do a big problem. In that, drawing FBD is one algorithm, constraints is another algorithm, solving equations is another algorithm. You're getting it? So it's like small bits and blocks of it. When you learn like that, you'll understand where you can change, where you need to modify. It will be more easy for you to understand. But if you study everything randomly, right, in one problem, you're mixing up everything from beginning, you will get confused. So let's see, I'll be giving you some shapes. You have to draw the FBDs for them. And you won't be able to send the answers. That's okay. Again, now, whenever I give you shape, right, don't think so much. Whatever you think, you draw. If someone is having a problem with FBD, the best thing is just draw whatever you think. And when I show you, see what went wrong. You will learn faster. So let's see your problem. I'll show you one. Let's say we have two blocks here. Now here, see, we are not interested in the values right now. So the question is, draw the FBD of both the blocks. M2. This is pushing here. N2, your own weight, M2G. Making baby sister is sitting in your lap. So if you draw the FBD of that kid, you're pushing the kid up, N2, the kid ka weight is acting down. There are only two forces on the kid. Now, if I ask you to draw the FBD of you, now see, the kid ka weight is not acting on you. Understand? The kid ka weight is not acting on you. What is acting on you is the kid ka normal reaction. Are you getting this? And coincidentally, N2 becomes equal to NG. Wo alag story hai. So if someone asks you this question, is M2G acting on M1? Wrong. M2G is not acting on M1. What is acting between M1 and M2 is N2. Are you getting that statement, everyone? The interaction between M1 and M2 is, because of N2, not the weight. And this own weight M1G and the ground ka normal reaction N1. There. That's the FBD. The block M1 does not know who is M2G. You can say like this thing, because of M2G, you created N2 and that N2 is acting on this. That is fine. End of the day, why you are? But technically speaking, M1 doesn't care who is M2. Think of like this. If you take a book and throw it on you, who is hitting you? The book. It is not me. It is the book. But I am responsible for throwing the book. But that's a different story. I hope this was clear. Now you guys try. Draw FBD of all the blocks. Don't worry about components and all that. Just the forces. I don't want anything else. Get it. You just draw whatever you think. I'll give 30 seconds, then I'll show the next one. And verify. You're confused, generate something, ask me, I'll explain you again. But you're clear, then it is great. Look at this guy. Your own weight, normal reaction. N3 is the interaction between M3 and M2. Your own weight, and N2 is the interaction between these two. N2, your own weight, and N1. Please check. So M1 does not know who is M2G, who is M3G. M1 is thinking, because of the weight on the top, right, the molecules are being pushed down, and because the molecules are pushed down, there's a repulsion, and that repulsion is N2. So indirectly, N2 is becoming M2 plus M3G, but the reason is different. I hope you're getting it. your own weight N3. N3, remember normal reaction is perpendicular to the surface. N2 ऐसा होना चाहिए. That should be perpendicular to that. Make sure your weight is always down, M2G. I know components and all. Right now we're not bothered about it. So on M1, this would be N2. This would be your own weight mg, and this would be your N1. Please check. Any doubts on ABC? Please ask. Clear, na, Monica?
Sir, in
How
the
good.
second block, the
Huh.
normal reaction should be N1, right? In the inclined
Yeah,
part.
this thing,
No, sir. C.
this one.
Yes, sir. Yes.
Meaning, see, if I call this N2, this should be N2. But you can call it whatever you want.
Okay, sir. Okay.
You're adding it mainly. If you call this N1, na, then ये भी N1 होना चाहिए. If you call this N100, na, this should be N100. I don't care what you want to call it.
Okay, sir. No, sir, because it was contact means that contact with block M1. So I thought
I know,
should
I
be-
got your point. अगर ऐसा है ना, I'm just lazy to write actually. We can write this as N23, N21, N1G. ऐसा लिख सकते हो, but ठीक है ना. You got the point, right? So main thing, it doesn't matter whatever variables you want. All clear with this? Turning the page. Let's get that. First is a wedge and a ball. Second is 3 balls stuck between 2 walls. Third is 2 wedges in 1 rod or something. And I'll send you a sheet on constraints and FBDs today. Easy stuff, but you should know how to draw your forces properly. Do ask me anyone is confused or you're not getting something. See. For every point in contact, there is a normal reaction. So you're touching here. You're touching here. So I'll just call this N wall. You can name whatever you want. It doesn't matter. N. Like I said, appropriate symbol. See, the main thing is this is mg. Because forces where they're acting is also important. And if this is N, this is also N. That's it. You can take whatever symbol you want. And this is your weight M1G. And this is N ground. Check. Then this thing M1, M2, M3. This is N1. I'll just call them N1. I'll call this N2. Then this also will be N2. This will be N3. This will be N4. This will be N4. This will be N5. And this will be N6. Your own weight M1G, your weight M2G, and your weight M3G. Please check. So there are total 1, 2, 3, 4, 5, 6. There are 6 normal reactions. N1, N1, N2G, N2, N2, N3, N4, M1G, and M2G. Please check. All the normal reactions won't be same. No, no. इसीलिए ना N wall, N ground, N. I use different names. It won't be same. Please check everyone. So the starting is drawing the forces properly. You mess up one force, and then there is no use of anything else. Writing equations, solving all comes secondary. You should know first of all how to draw the forces properly. Step by step, like I said, the main two things is constraints is one part, free bodies is one part. You know, these two things, solving problems is solving is kind of easy. But most people go for their basics only. Clear?
First, on a stationary
madam.
table, won't there be any
Yeah.
normal acting upwards?
Yeah, it will due to the ground, na?
No, not no, the legs of the table that will act on the surface, but the open surface, will it act? Will it show any normal?
On whom? What is your system? First define that.
A
What is
stationary
your system? Table,
where
log again.
no, nothing is up there on the table.
Okay.
Then what will mg or the legs of the table, and
Yeah.
then the upper surface of the table, will that show any contact with the mg will
With
come
whom?
upwards, but then upwards.
Yeah. And 4 normal reactions. Bas ho gaya.
Nothing on the upper.
Nothing there. It is not. Arey, why do you get normal reaction? When you touch something, what are you touching? You're not touching anything, right? Next thing, that is one. Now, what if you have strings also? Let me show you this one. So if you have M1, M2, and if I ask you to draw the FBD, M1, M2, I can even draw for the pulley also. So this is tension, tension. So strings always pull. Remember tension, tension. It is the same string, so tension will be same. M1G, M2G. For the pulley, T dash. So this will be T dash. Strings pull, and strings pull. There. I can even draw the FBD for the pulley also can be asked. You can literally draw FBD for anything. So it's like 2 blocks hanging with the strings. Let's say this is 3M. This is 2m and this is m. हाँ रे
सर पुली के उसमें mg नहीं आएगा.
ले सकते हो. I took a massless pulley, but ठीक है ले लेते हैं. Mass of pulley into g. Generally take just do FBD of the blocks, okay? Don't draw for pulleys. I'm just showing you. Get them. None? See, this thing, if I take tension to be T, this will be T, this will be 2T, so this will be 2T, this will be 3mg, this will be 2mg, this will be mg. I'm not drawing separately, I'm just drawing it on the same. I is a good one, right? The wedge part is more important. Let's see whether you got that right. So this is M2. We have tension. Weight M2G is downward. I know we can divide the components. We'll see later on. This is a normal reaction. Let's call it N2. That's it. There are only 3 forces acting on M2. On this M1, I can always include the pulley, or I can simply say 2T. Anything will do. This is M1G. So basically, I like to include the pulley with the system generally. Or you can simply also say this is T, and you can simply say this is 2T. वो भी चलेगा. Now listen to this thing. This is the one thing most people mess it up. Since the pulley, right, is fixed to the wedge. Can you see the support? It is fixed to the wedge. You have to include the pulley. N2, strings always pull. Tension, tension. Most people forget these two tensions on the system. If a pulley is fixed to a wedge or to any block, it doesn't matter. And if the string is passing over it, the strings will also pull that pulley, and the pulley is pushing the wedge. And N2, your own weight M3G, and the normal reaction on the ground. There, this is important. The pulley will actually create 2 forces there. Clear? Any doubts on this thing? Please ask GHI. Since pulley is fixed to wedge, it has to be included. If you say, sir, I don't want to take the pulley, problem ये आएगा, then ये rod का force भी लेना पड़ेगा ना? And I don't know how to find that. So always include the pulley. Include the pulley in FBD. Let's see one more.
So can you go back for a minute? Yes, sir.
We have done this in constraints. This is M, this is capital M. Draw the FBD of them. Tension, tension, tension. Strings always pull. Normal reaction, your own weight, and the normal reaction on the ground. Check. There'll be 3 tensions there. 6 forces. Tension, normal reaction, your own weight mg. Please check your forces. Easy, got this? Hope everyone is getting a clarity about FBDs. Next thing, equilibrium. Now this thing, right? Equilibrium, we did some problems in vectors. So we will skip some of them here. So you can refer more about equilibrium problems in vectors also. But let's do a few ones which we didn't do there. So that is the main thing, FBDs. Now you know how to draw. Want it to be 2, 2 for the first FBD. What 2T? Which one, Anika? The upper one or the bottom one you're talking? Isn't this the same string? This one you're saying? That should be T and T only, na? Both are at angles, na? 2T kaisa hoga? Strings always pull, na? T and T. Why were you getting 2T here? Observe this. Both were in same direction, so you're getting 2T, right? They're not in the same direction. Okay. What is equilibrium? A body is said to be in equilibrium if net force is 0. Now be careful, a body can go with constant velocity. If body is in equilibrium, does not mean it is at rest. It can go with a constant speed. Constant velocity. Remember, uniform motion or at rest. Theoretical question. A body is in equilibrium implies the body is not moving. Wrong. So if you have a body here acting with forces F1, F2, F3, and F4. So the net force F1 plus F2. We have done exact same thing in vectors. The 0 vector. If a body is in equilibrium, the component of forces in any direction cancel out. They should cancel out. If they don't cancel out, means what? The body is going in that direction. It doesn't make sense. Let's see a few problems and then Clear? Any doubts on this? Venkatesh, to keep your cam on. Let's see our problem. 22. Find M by M if the system is in equilibrium. Capital M by small m. Let's get this. Easy stuff. Finish it off. Don't take much time. Drawing the question is actually takes more time. Solving is easy. Find M by M if system is in equilibrium. Are you sure, Mahan? मैंने कुछ modify किया. Must have seen it somewhere and you remembered it. We'll do some good problems in the next class. Next class, things will start moving. Look at this. Let's start from here. Let this be tension T. You can take anything. This will be T by 2, everyone. You're going up, right? And this guy will be T again. This will be 2T and this will be 4T. This is 4T. This is small mg. Free body diagram. 4T should be equal to small mg and capital mg. So T should be equal to capital mg. Divide them. So we get M by M is equal to 4. Take this as T, 2T, 4T. T, 2T, and 4T. We have done this in constraints. This is capital Mg and this is small mg. So 7T is balancing capital Mg, 1T is balancing small mg. M by M is 7. Sure, check. Just need to write the forces and equate it to the weight there. In this case, masses will not move. I said equilibrium, no? So there is no acceleration. So you can write tension is equal to the weight directly. Okay. Clear? Find M by M, system is in equilibrium. Same question. System is at rest.
Can you go back for a minute?
Hmm.
Yes, I think.
Here you have to take components. And this components, where did we learn? We learned this thing. You guys did this thing. You just don't realize maybe. We learned it in kinematics. Where in kinematics? Projectile on inclined. I taught you how to divide components, mg cos alpha and mg sin alpha. I'll show you anyways. And more problems, right? In equilibrium, we have done this in vectors. So we will spend little less time on this, but here also, if you remember, I taught you how to divide components, mg cos theta, mg sin theta. We did a few problems here on equilibrium, forces, tension, strings. You can just refer to this thing. We did some pretty good problems there. We will do other varieties here. So this thing, how you divide into components. Remember this thing, mg. So this is your mg. This is theta. This is theta. So this component is adjacent side, mg cos theta. This will be mg sin theta. Perfect. Now, when you draw FBD, henceforth, you will take components now. Mg sin theta, mg cos theta, normal reaction, and tension. Since it is not moving, tension is balancing mg sin theta, n is balancing mg cos theta. I didn't ask you that, but take care. So if this was the tension, this was T, and this was T, and this was capital Mg. So we simply write there 2T is equal to capital Mg. So we get 2mg sin theta is capital Mg. So m by m is 2 sin theta. Check, easy. Getting this? Any doubts on this? Let's see one more. Find F and normal reaction on the ground. The body system is at rest. But what is T, Ronak? T is not given. Only capital M and small m are given. You have to give the answer in the terms of variables that are given. Tension, tension, normal reaction, tension, normal reaction on the ground, mg, and this is F. There are 7 forces. Tension, small mg, and normal reaction. Now understand, since it is not moving here, T is small mg, N is 0. Normal reaction between the blocks is not there. And here we can see F will be 2T, that is 2 small mg. And the normal reaction on the ground will be 1 mg plus T, which is mg plus small mg. That is how you check it out. Yeah, right, Ronak. Because horizontally there is no other force only to balance. There is only one single N in the horizontal direction. So that is 0. Is this making sense, everyone? Please check it out. Ask me if you're confused. Not tough, but you have to be a little careful. So most people, what they do mistake. If I ask you what's the normal, they say N is equal to mg. That's a blunder they do. They forget this tension which is pulling down. So the normal reaction on the ground need not be mg every time. Which normal reaction, Anusha? Between the blocks or the ground one? Between the blocks, think about it. Now, in the horizontal direction, how many forces are there? One force. What is the net force? 0. So there's no other force, means what N is 0. And Anusha, think like this thing. The force between them will come only when this thing starts moving, right? If you're not moving, you're just hanging there. You're getting it? That way. All clear with this? Last one for the day. Mass of the pulley is M. This is the rod. Find the force acting on the rod. Supporting the pulley. This is a standard question. Finish off. Just finish it off. Let's see. T ka value is not given, right? You have to tell me the answer in terms of M. Look at the FBD here. Tension, tension, your own weight mg. And this is that force due to the rod. I'll just call it F bar since I don't know what it is. And if you look at the block here, that would be tension and that would be small mg. So tension is small mg. Since it is in equilibrium, F bar should be equal to, you can write that in vectors actually if you want. F bar minus Ti cap minus Tj cap minus mgj cap is equal to 0. So we get the force will be T I cap plus T plus mg j cap. That would be mg I cap plus m plus mg j cap. That's your answer. You want the magnitude, square them and add them. The force is actually providing the horizontal component and the vertical component. Check. In the vertical direction, T plus mg is acting together and T is pulling. Remember, strings always pull. If there is a string connected to something, it pulls. Okay, so we will do more on this thing in the next class. I'll just add it here. Refer vector equilibrium in vectors. We did more varieties there. We will do more complex ones in the next class. And on Friday, things will start moving. So the actual thing starts. It's more fun. Okay, I think with that we'll wrap up for the day. So any doubts, anything you can stay back and ask. Also free to leave. I'll see you on Friday at the same time. We'll continue from here. The test will be online today night. I'll post the results also. There are a few corrections. I'll get them done and I'll post the results.